All right, so we're about to write our first equals method. And I've got set up here a fraction class. We'll just say a fraction consists of a numerator and a denominator. Okay, so your boss is going to tell you what to do. Your boss might be your professor in college, your manager in the workplace. Of course, it's the college board or your teacher in high school. Okay, so we got some options. We could say two fractions are equal if they have the exact same numerator and denominator. Okay, you can assume they're all reduced down, right, with the least common denominator. You can assume that, and that would be one way to do it. Does one fraction's numerator and denominator equal the other fraction's numerator and denominator? That would be a way to do it. We could do it different ways. We could say if when you divide numerator by denominator, their quotients are the same. That way you wouldn't have to reduce them, right? So, well, whatever, okay? You see, both of those are good ways to do it. Okay, so let's do it this way first. We could say two fractions are equal if they have the same exact numerator and denominator. So I've got three fractions over here in my tester. The first one is 2/3, right? Two numerator, three denominator. The second one's 1/5, and the third one's also 2/3. So hopefully we'll write some code that tells us fraction 1 and 3 are equal, and fraction 1 and 2 are not equal, and so on. Okay, so here's how we set it up. Just like when you write the toString method, you know what the signature is. Public string toString. When you write an equals method, it's always, always, always the same signature. Public, Boolean, going to return true or false. True if they're equal, false if they're unequal. Public Boolean equals. Now comes the funny part. Object other. Okay. Object other. Remember, object is the cosmic superclass from yesterday's lecture, chapter lesson 35 of the textbook. All classes extend object. That means all objects are also object objects. Okay, it's like the mother of all classes, the object class. But that's going to cause some concern here because we wish it said fraction other. That would be a little nicer, wouldn't it, if it just said fraction there. But if you put fraction there, you would not be overriding another new word. You would not be overriding the equals method in the object class. Okay, a lot to think about for a little tiny method. Okay, so if you're doing this the first time, we're all new programmers here, you might guess you could do something like this. If something return true, else return false. Okay, and we can do something like that. So again, our directions from our boss, from our professor, from whatever the question in the AP exam says two fractions are equal if they have the same numerator and denominator. So all we do is say if numerator equals other dot numerator. Now this is wrong, I'm making a common mistake here. If numerator equals other numerator, and as the direction said, and denominator equals other dot denominator. Now we're almost good there, but we have a mistake. Again, I'm recording this video for us, and it'll be on the website, my YouTube channel tonight. Okay, so you can come back and check it out and practice it one more time at home tonight. But does that kind of make sense? Look at my lines of code in the tester that use the equals method. They're the last two lines of my tester. Again, this is brand new code for all of us, so it's at least a little bit challenging. I've got f1 dot equals f2. So f2 is the argument, the parameter, right? That's what's getting stored inside object other. Do you see it passed in there? You know that. In the parentheses is f2, fraction f2, and it's being passed to the method equals, and it becomes object other. Now f1 is the fraction object that gets us into the class. So in this crazy if statement here, again, our first time seeing something like this, isn't it? In this crazy if statement, the numerator refers to f1, and the other dot numerator refers to f2. You got to get that part first. f2 is object other. Very abstract, isn't it? Very abstract. Okay, now I got that in there. It's all set up. It's pretty nice, but it's not going to work. When I compile this, it says it cannot find numerator. And you say, what the H again, right? What's going on here with Java? I mean, it didn't highlight in red the numerator to its left. You see that? It found that numerator. It found f1's numerator, but didn't find f2's numerator. Well, it found f1's numerator because f1 is a plain old fraction. In this fraction class is the numerator instance field. But it couldn't find f2's numerator because we're storing it into an object, and numerator is not in the object class. Do you see it? It's like yesterday's lecture, where it wouldn't compile if the method was not in the superclass. Right, Josh? It's not going to compile. Same reason. When you see today's practice quiz you're doing for tomorrow's real quiz, we got stuff like this all over it from yesterday's lecture. So what can we do? Well, the first line of an equals method, everyone I've ever written, I think, has something like this. We say fraction f equals a cast of fraction for other. Now other is a fraction. We made it a fraction. And so we don't put other dot numerator, we put f dot numerator. And now I'll cross my fingers and see what happens. Good, all good. Does my tester compile? Yep, all good. And let's run that client and see if f1 equals f2 is false, right? 2/3 is not equal to 1/5. But f1 dot equals f3 is true because 2/3 is 2/3. Okay, that's our first equals method of the year. Okay, and it's up to the programmer to choose what makes the objects equal. Right? I could have said if their quotients are equal, they're equal. That would make like what? 1/3 equal to 2/6. Right? We could do it that way too. We could divide it out and make sure they're close. maybe within 0.0001 or something of each other, that would make it true. That could have been my directions for us. But I just said if they're equal, assuming they're already reduced.